1-4 complex numbers is going to be really, most students like it. How about that? We'll phrase it that way. All right, so the imaginary unit I. So I is the square root of -1. Do you guys remember when we were trying to take a square root, it couldn't be negative? Well, math people were nice and they fixed that, so we can still work those out now. I know you really wanted to be able to work those out now. But anyway, so square root of square root of -1 is I. So if I equals the square root of -1, what's I squared? Yeah, -1. All right, what about I cubed? All right, do you guys agree that I cubed is the same thing as I squared times I? And you guys said that I squared is the same thing as -1 times I. So I cubed is the same thing as -I. That's a bad I. Let me fix it. There. So I cubed is the same thing as -I. It didn't get any better. Sorry. Here. There. Change color. All right, what about I to the 4th? Yeah, it's just going to be 1. Because I to the 4th is the same thing as I squared times I squared, which is the same thing as -1 times -1. Is that okay? All right, super. Okay, so complex numbers and imaginary numbers. The set of all numbers in the form a plus bi, and a and b are going to be real numbers, is going to be your complex number. So a number that's part real, part imaginary is called a complex number. We put the real part first. So the part without the I comes first. The part with the I comes second. Also, it says that b can't be 0. Because if b is 0, then there's no I, right? 0 times I is going to be 0, so then we're just left with a real number, which isn't what we're really concerned about right now. So I want you guys to go through and see if I can get all of them on there. Yeah. I want you to go through and identify the real part for all of these and the imaginary part for all of these. What's the real part of the 2 minus 4i? Okay, what about the imaginary? Minus 4i. What about the -7 plus 3i? Yep. All right, what's the real part for minus 5i? 0. Minus 5i for the imaginary. All right, what's the real part for 18? And for the imaginary? Yeah, there isn't one. We're going to call it 0i just to be nice about it. All right, 2.3 minus 5.9i. What's the real? About the imaginary? Very nice. Okay, what about the next one? What's the real part? Yes, and what about the imaginary? Yeah, and I'll take this moment to say, so they put the I in front, which seems a little bit weird because we've been doing the number times I. With square roots, they're going to put the I in front so that you make sure you're not trying to take the square root of I. Because if you write it at the end, it's really easy to not know if it's under or not under. So they'll do the I and then the square root. So 3 minus I, real part. And imaginary? Yep. And what about for 5i minus 6? Imaginary? Yes. Is that okay? None of it was too tricky? Okay. All right, adding and subtracting. Again, you guys are really going to love this section. I love this section. So to add, if this was just a normal set of polynomials we're adding, so we had something like 3x plus 2 plus x minus 7. We would just go through, because it's addition, we would drop the parentheses. So we'd have 3x plus 2, and then plus x minus 7, and we combine like terms. So 3x plus x, we would give 4x, 2 minus 7, I'm going to get negative 5. Yeah? Okay. I want you guys to try 1. It's the exact same idea. You're just going to combine like terms. The real part goes first. The imaginary comes second. And if you do 1 really quickly, go ahead and do 2 and 3. All right. Hopefully 1 wasn't too bad. So what did you guys get for your answer? 2 plus 5i? Yes. So you put that negative 2 and that positive 4 together. And then you have the 6i, positive 6i minus I, which is minus 1i, to get the 5i. Everyone okay with that one? All right. You would want to put it with the real part first. Yeah. All right, for number 2, I'm going to actually take a second to do the next step, what's the next step going to be? Yeah, we're going to distribute that negative, right? So we have negative 7 plus 5i. Exactly, and then minus the 11i. Okay, and now it's right back to what we were doing. Combine like terms. So what's your real part? Okay, and what's your imaginary part? Yeah, negative 6i. So 2 minus 6i. Is that okay? You guys like these so far? See, they're not bad. Like is relative. All right, for 3, same idea. We need to distribute first. So we're going to have 15i minus 12 plus the 11i. So what's my answer going to be? Very nice. Negative 12 plus 26i. I was waiting to trip you up and have you guys put the i's first. Yes, got to remember to distribute first. Definitely. All right, we're going to go through and do some multiplication. Again, this is the same. If you pretend like the i's were x's, you're going to do the exact same thing you would have done before. The only trick is we're not going to have I squareds. So I'm going to walk through the first one with you and let you guys try the second and third one. So for the first one, so we need to distribute, get rid of the parentheses. So we've got negative 8i times 2i is going to give us a negative 16i what? Yep, I squared. And then we have a negative 8i times the negative 7. Exactly. Positive 56i. Now the big trick is I squared. You're never going to actually write I squared. I squared is the same thing as what? Yeah, negative 1. So I've got negative 16 times negative 1, so I just have 16. So 16 plus 56i. Is that all right? It's exactly the same as with the x's. The only trick is maybe you get I squareds. You guys go through and try 2 and 3. All right, for number 2, we're going to go ahead and start. Did you guys think to FOIL it? Yes. Perfect. All right, so whenever you did your FOILing, what was the first thing you got? Okay, negative 12, what? Minus 4i, and then? Minus 24i, and what else? Yeah. So we know this is going to be the guy we got to really think about. So we'll go ahead and make another row. So I've got the negative 12. We're going to combine these. So you got the negative 28i. And then this guy, and I'm sure you guys are catching the trend, but really you're just changing the sign, right? Because it's going to be the negative 8 times negative 1, so it's going to be a plus 8, but we're going to show it for a while. So we've got the negative 12 minus 28i plus 8. So now if I combine my like terms, my final answer is going to be perfect. Negative 4 minus 28i. That one okay? All right, good. Let's do number 3 real quick. All right, so again with the foiling, what's the first thing you get? Okay, 4 plus 10i minus 10i minus 25i squared. And again, that's the minus 25i squared is going to be the weird one. So we got 4. These guys canceled out, right? Plus 10i minus 10i. And then it's a minus 25 times negative 1. So it's the same as 4 plus 25. Yeah, so we just end up at 29. Is that okay? All right, so did you guys pick up that these are the same terms with opposite signs in front of the imaginary part? Yeah, it's like the difference of squares. So it's the same. So you've got the same real part, and then the imaginary part is the same except for the sign. So 1 we just did. So you guys saw, because it was the same parts with opposite signs in front of the imaginary portion, that it canceled out. So I want you guys to do number 2 really quickly and see if the same thing happens. All right, so whenever you foiled, what was the first thing you got? 9. It was a positive 9. I was waiting to trick some of you. So the negative 3 gives a positive 9. All right, negative 3 times the negative 8i. Okay, plus 24i. And then the 8i times negative 3. Minus 24i. Well, that's good. And then 8i times negative 8i. Yeah. So negative 64i squared or minus 64i squared. Same thing. So this is the guy to pay attention to, and these two canceled. So we end up with 9, and then the minus 64 times negative 1, which is the same thing as 9 plus 64, so you ended up with? Is that all right? Okay, so up here in our nice little conjugate of a complex number, so conjugates, whenever you've got two pieces and you change the middle sign. So you've got so 2 minus 5i, its conjugate is 2 plus 5i. The conjugate of the minus 3 plus 8i is the minus 3 minus 8i. So again, we're just changing that sign in between the two. And it's got the shorthand version of what's going on here, and we'll do the shorthand version, excuse me, for number 1. And it says if you've got complex conjugates, you just do a squared plus b squared. So a squared is going to be this 2, because again, these are in the form, this is a minus bi, this is a plus bi. So the 2 is the a, we square that, we get 4, right? Okay, and then it says plus comes next, and then we take the 5 and square it, we take the b and square it. So we're going to get 4 plus 25. Which is the 29, and that's if we do the shorthand way. Is that what we got on the last page? Yeah, that's exactly what we got on the last page. If you catch that, or if you remember that, and you feel confident you're going to remember that, go ahead and do it. That's great. So just following the formula up here, if you have the a minus bi times a plus bi, you take your a, which in this case is our 2, and square it, plus b, the b squared, and the b is at 5.
So what do you do with the i's?
They cancel out. So, because it's just like over here.
Plus and minus, right?
Exactly. So the right over here with the plus 24i minus 24i, and on the last page the plus 10i minus 10i. Yeah, so the i's will cancel. So these complex conjugates become pretty useful, because if you know what the conjugate is, you can get rid of the i's, right? You can just make it a real number. Part of the reason that's really important, do you all remember that you cannot have a square root on the bottom of a fraction? Okay, you can't have an imaginary number down there either. So we need to get rid of imaginary numbers. So whenever it'll say stuff like dividing complex numbers, I actually think about it more like multiplication, because all we're doing is rewriting the same thing, but we're making sure we get the I out of the bottom. So based on what we just talked about, what would I need to multiply 3 minus I by to get the i's to cancel? Yeah, so we need to multiply by 3 plus I. This is a fraction. Can I just do that? Top and bottom. Perfect. So we're going to have 3 plus I on top and bottom. So on top, we're going to distribute across. So the 2 times 3 is going to give us 6. And then 2 times I is going to give us plus 2I over. And then here, if you want to do the shortcut way, you can, but I'm going to do it the longer way. So 3 times 3 is going to give us 9. And then 3 times I is going to be plus 3I. Then we're going to have negative I times 3, so minus 3I. So now we're feeling really good. Then we have negative I times positive I, which would be negative I squared. So the top stays the same. The top's going to say that's 6 plus 2I. And then on bottom, we have the i's cancel, and then we're going to have 9, and it's minus I squared, which is the same as, so it becomes a positive 1. It's the same as minus negative 1, which becomes a plus 1. So if I have 9 plus 1 on bottom, I've got a 10. Yeah. All right, and then one more step and we'll call it good. Well, I lied. 2 more steps and we'll call it good. So the next step, we're going to split this apart. So if I split it apart, all I'm doing is put the denominator underneath both parts of the numerator. So we've got 6/10 plus 2I over 10. And then last step, we're going to reduce this. So 6/10 reduces to, 3 over 5. And then for the second part, what's 2/10 reduced to? Yeah, so 2/10 reduces to 1/5. And I'm going to write it as 1/5 and then put the I beside it because I think my math lab might care. So we'll do it the way my math lab prefers. Yeah, so technically that's dividing complex numbers, but there's nothing that feels like division about it. So if it says divide complex numbers, what it really means is multiply top and bottom by the complex conjugate. So you guys try 2. Oh, splitting it apart? So the question was, how did I go from the 6 plus 2I over 10 to the 6/10 plus 2I over 10? We're just taking it and going backwards with how we add fractions. So we might have something like, or let me rephrase. If we had something like 3/5 plus 1/5, well, common denominator means that we can just add the tops to get 4/5. Since we can't actually get to this place because we have a real and imaginary part, so we're starting from here and just kind of going backwards. So you're just taking each term on top and putting it over the denominator. Yeah, good question. All right, for number 2, what did you multiply by? Yeah, 4 plus 3I. So top and bottom. All right, so on top, we distribute that 8I across. And what did you end up with? 32I plus 24I squared. Okay, very nice. All right, and on bottom, what did you all end up with? Okay, 16. All right, some of you did it a short way, some of you did it a long way. I'm going to go ahead and write out the longer way. Even though if you took the shortcut, that's great. If you took the shortcut, you'd just be adding plus 9, right? Okay. So I'm going to take the longer way. So 4 times 3I is going to be plus 12I. The negative 3I times 4 will be minus 12I. The negative 3I times positive 3I is going to be a negative 9I squared. All right, so now we do a couple things. Cancel those out, and I'm going to rewrite these I squareds as negative 1s. So on top, we have 32I plus 24 times negative 1 over 16 minus 9 times negative 1. So if I come back down, I start to get it a little bit more together. So I got negative 24 here plus 32I. Because we got to put the real part first. And then I've got 16 plus 9, which gives me 25. Okay. And then to make my math lab happy, we're going to split it apart. So we've got negative 24 25ths plus 32 25ths I. Does anything reduce? Nope. So we're done. Just labeling. All right, for 3, what'd you guys multiply by? Yeah, 7 plus 2i. All right, so I'm going to speed us up a little bit. I'm going to do a short method for the bottom. So the short method is take the a, the 7, and we're going to square that and get 49. And then plus, we're going to take the b, that 2, and square it. So 2 squared will give us 4, exactly. So there's our quick method for the bottom. And now we need to go across top and actually FOIL this out. So we got 4 times 7, give us 28. 4 plus 2i is going to give us 8i. 3i times 7 is going to give us plus 21i. And then 3i times 2i, it's an I. So 3i plus 2i is going to give us 6 plus 6i squared. So the 28, we're going to keep by itself for a minute. The 8i and 21i we can put together. So plus 29i. And this plus 6i squared, same as 6 times negative 1. So I can just put minus 6. Is that okay? All right. And then all over 53. So we're getting close. Last thing we need to do is combine like terms and split it apart. So 28 minus the 6 is going to give us, okay, so 22. And I'm going to go ahead and put that over 53. And then I have plus 29 over 53 for the imaginary part. So 29 53rds I. Is that okay? I shorthanded that one a little bit. So principal square root of a negative number. Whenever you see square root and it has a negative in there, the very first thing you need to do is pull out the I, okay? So instead of having square root of negative 81, I'm going to immediately rewrite that as I times the square root of 81. And then minus, and again, the square root of negative 144, I times the square root of 144. Because we're pulling that negative 1 out. And then once we do that, it gets a little bit easier. So the square root of 81 is what? Yeah, so if I pull that out, then I've got 9i minus square root of 144. So 9i minus 12i gives us what? Yeah, so negative 3i. Is that okay? Yeah? All right, try number 2. It's a little trickier. Okay. All right, I'm going to jump into 2. I'm going to do a couple of the steps first. So first thing again, pull those i's out. So this is the same as 5i square root of 8 plus 3i square root of 18. All right, 8. What is 8? Yeah, it's going to be 2 root 2. So I'm thinking about it as 5i times 2 root 2. But really, that's just going to be 10i root 2. All right, and then we have plus square root of 18 is what? Yeah, 3 root 2. So we have 3i times 3 root 2. So that's really plus 9i root 2. All right, hopefully you guys remember in your rules about radicals. So what happened here? Yeah, so 19i root 2. How's that for a nice answer?